welcome back. Excuse me, we're starting chapter 2. We're going to be talking about polynomials and rational functions. Now, we need to talk about completing the square before we can really begin chapter 2. So completing the square is a process which allows you to write an expression in the form of x squared plus bx as the square of a binomial. It's going to help us solve quadratic equations by using square roots, another way to solve a quadratic. Now, we're going to start by solving by square roots. So we're going to take the square root of both sides to isolate the x minus 2. And when we solve by square roots, we get two solutions. We get that plus or minus 3. Now to isolate, we add 2 to both sides. X equals 2 plus or minus 3. Now we can do better than this because we can say that x equals 2 plus 3. And x equals 2 minus 3, so we get x equals 5, and x equals negative 1. Those are our two values of x that work. Number 2, isolate, so we're add 5 to both sides. X plus 1 squared equals 5. Take the square root of both sides, x plus 1 equals plus or minus. Now we can't simplify it, it's just the square root of 5. Subtract 1 from both sides, so x equals negative 1 plus or minus the square root of 5. And that's all we can do with that problem. Now, solving using completing the square is all about getting that perfect square trinomial. So here's two examples of perfect square trinomials. So x squared plus 6x plus 9 is x plus 3 squared. X squared minus 4x plus 4 equals x minus 2 squared. As we know, that's not always the case. What completing the square does is it makes that the case for us. You can read these directions as we go through, but I'm going to start by doing examples. So what I want to do is I want to first start by isolating my x squared and 6x. My leading coefficient is 1, so all I have to do is subtract 8 from both sides. So I have x squared plus 6x. I'm going to leave some space, and that equals negative 8. And now what I'm going to do is I'm going to add the middle term. We get x squared plus 6x plus 9 equals negative 8 plus 9. So when we factor the left-hand side, we get x plus 3 squared equals 1. Remember, we picked that 6 over 2 squared to both sides so we could get a nice perfect square trinomial. Now we take the square root of both sides, x plus 3 equals, don't forget, plus or minus 1. Subtract 3 from both sides, so x equals negative 3 plus or minus 1. We can do better. X equals negative 3 minus 1 is negative 4. Negative 3 plus 1 is negative 2. There's our two solutions. Moving to the next page. Problem number 5. We already have the x squared and the negative 6x isolated. So what I'm going to do, and our leading coefficient is 1, x squared minus 6x, I'm going to leave some space, equals negative 7. Now I want to leave that space because I'm going to be adding the negative 6 divided by 2 squared to both sides. So it gives me x squared minus 6x plus 9 equals negative 7 plus 9. When we factor the left-hand side, it's a nice perfect square trinomial. It's x minus 3 squared, and that equals 2. Take the square root of both sides. X minus 3 equals plus or minus the square root of 2. Add 3 to both sides. Our solutions are x equals 3 plus or minus the square root of 2. And there's our two solutions. We're going to go to problem number 9, because now our leading coefficient is 2. We have to divide each term by 2. That gives us our new equation of x squared minus 2x minus 7 equals 0. Isolate the x squared and the negative 2x by adding 7 to both sides. X squared minus 2x, leave some room, equals 7. And in that spot, we're adding negative 2 divided by 2 squared. We get x squared minus 2x plus 1 equals 7 plus 1. So when we factor it, we get x minus 1 squared equals 8. Take the square root of both sides, you get x minus 1 equals, don't forget your plus or minus. Now the square root of 8 can be simplified. It's the square root of 4 times the square root of 2, 2 square root of 2. And now finish up by adding 1 to both sides, x equals 1 plus or minus 2 root 2. And there is our answer. Up the difficulty a little bit by having that coefficient in front of the x. Let's go to problem number 11 now, please. Now, our leading coefficient is 3. We're going to divide each term by 3, including the 0. So our new equation is x squared minus 12x plus 50 equals 0. Isolate by subtracting 50 from both sides. X squared minus 12x, leave some space, equals negative 50. Now in that space we're going to be adding the negative 12 divided by 2 squared to both sides. So you get x squared minus 12x. And now negative 12 divided by 2 is negative 6. Squared is plus 36. All right, so on the left-hand side we can factor. It's going to be x minus 6 squared equals negative 14. Take the square root of both sides. X minus 6 equals plus or minus. Now the square root of negative 14. Square root of negative 1, the square root of 14. If you remember, the square root of negative 1 is I, our imaginary unit. So it's I times the square root of 14. And then we just add 6 to both sides. X equals 6 plus or minus I times the square root of 14. And there it is. For our next set of problems, we're going to be writing from standard form, or general form, into vertex form. So now, to get in that vertex form, we're going to keep it as f of x. Now, just like we did before, I want to isolate my x squared and 6x. My leading coefficient is 1, that helps. I'm going to start by subtracting 3 from both sides. So f of x minus 3, leave some space, equals x squared plus 6x. Now, what we're doing is we're adding the middle term, 6 divided by 2 squared. So it gives me f of x minus 3 plus 6 divided by 2 is 3, squared is 9, equals x squared plus 6x plus 9. So f of x plus 6 equals. Now, you might notice that I'm factoring these really quickly, and that's because I know it's going to be an x in the first spot, and the second number is always going to be what's inside the parentheses being squared, including the sign. And 6 divided by 2 is just a positive 3. That's how I know a plus 3 goes there. And you'll see for the previous examples, it's the same thing. And now I just have to isolate by subtracting 6 from both sides. So my function f of x equals the quantity of x plus 3 squared minus 6. And there is our function in that vertex form. And our vertex, if you remember our rules, is going to be at negative 3, negative 6. You always take the opposite of what's in the parentheses. We're going to move to more challenging problems. Number 15. Now what makes 15 more difficult is we have the 2. So I'm going to start by dividing each term by 2, including the f of x. Now there's multiple ways to do this. I find this to be the easiest way to do it. So it's f of x over 2, don't worry about the fraction, equals x squared plus 8x plus 29 halves. You need to isolate, so I'm going to subtract the 29 halves from both sides. Don't worry about the fraction. F of x over 2 minus 29 halves, leave some space, equals x squared plus 8x. Don't worry about the fraction, let the math do the work for you. So we're going to be adding the 8 over 2 squared to both sides. So I get f of x over 2 minus 29 halves plus 8 divided by 2 is 4, squared is 16, equals x squared plus 8x plus 16. Normally we'd have to add these fractions. I don't even care about that. I'm going to leave it just as is. F of x over 2 minus 29 halves plus 16 equals, and when we factor we get x. And remember, you can always find out the number by taking 8 divided by 2, including the sign, so it's a plus 4. Now I can have the fraction. You can't have the f of x over 2. I want f of x. So what I can do is I can multiply each term by 2. Once, twice, 3 times on the left-hand side, and then on the right-hand side, multiplying by 2 again. So I get f of x minus 29 plus 32 equals 2 times the quantity of x plus 4 squared. I told you not to worry about the fraction. The fractions are gone. F of x plus 3 equals 2 times the quantity of x plus 4 squared. Subtract 3. F of x equals 2 times the quantity of x plus 4 squared minus 3. There's our function in that vertex form. And our vertex is at -4, -3. This isn't the only way to do it. It's one of the ways to do it. I find this to be a little bit easier. Some of the other ways, it requires a couple extra steps of thinking, whereas this one is just purely mathematical. We'll do 2 more, 17 and 19. So for number 17, same thing. We're going to start by dividing everything by -1. So I get a -1 times f of x equals x squared minus 4x minus 4. Need to isolate, so I'm going to add 4 to both sides. Negative f of x plus 4, leave some space, equals x squared minus 4x. And in that space, we're going to be adding the -4 divided by 2 squared. So I get -1 times f of x plus 4. -4 divided by 2 is -2 squared is plus 4 equals x squared minus 4x plus 4. So we get -1 times f of x plus 8 equals the quantity of x minus 2 squared. Okay, so with this, what we can do is to get rid of the negative, multiply every term by -1. So I get f of x minus 8 equals -1 times x minus 2 squared. Finish up by adding 8 to both sides. F of x equals the opposite of x minus 2 squared plus 8. So what you get is your vertex is at 2, 8. That is rewriting using completing the square to take it from that general form to standard form, that vertex form. Now, here's something interesting. Solving ax squared plus bx plus c by completing the square equals 0, by completing the square. Now, this is going to be a little bit difficult. It's not going to be on the test or quiz on how to do this. Same rules apply. So divide everything by a. You don't need to copy this down, but I think it's important for you to watch. So we get x squared plus b over a times x plus c over a equals 0. So I'm going to isolate, so I subtract c over a from both sides. Like I said, just watch. X squared plus b over a times x equals negative c over a. So what I'm going to be doing is I'm going to be adding, just like before, the middle term, in this case b over a, divided by 2 squared. So So I get x squared plus b over a times x. Now that's a messy number there. So I'm going to work off to the side. B over a divided by 2, I'm going to square that. So we don't divide fractions, we multiply by the reciprocal. So what it is, it's b over a times the reciprocal of 2, which is 1/2 squared. So what that is, it's b over 2a squared. And when we square that, we square everything. B squared, 2 squared is 4, and then a squared. So it's plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. All right. On the left-hand side, it's easier to factor than it looks. It's x. And now, remember, the next number is just going to be plus, because it's a positive, b over 2a. It's right there from when we divided it by 2a. Equals negative. Now, before I do that, I'm going to get a common denominator. So to get that common denominator, I have to multiply the numerator and denominator by 4a. Because my common denominator is 4a squared. So I get a negative 4ac over 4a squared plus b squared over 4a squared. All right. So I get the quantity of x plus b over 2a squared equals, now when I add these up, I'm going to put the b squared first, b squared minus 4ac, all divided by 4a squared. It's messy, I know. Now to solve, we take the square root of both sides. X plus b over 2a equals plus or minus. Now I'm going to do that square root off to the side here. The square root of b squared minus 4ac over 4a squared. Because of the quotient property, we split them up. B squared minus 4ac, that square root goes on top. And on the bottom, the square root of 4a squared. So we get the square root of b squared minus 4ac over. Now when we take the square root of 4a squared, we take the square root of 4 and we take the square root of a squared. So that gives us a 2a in the denominator. So it's plus or minus b squared minus 4ac, all divided by 2a. And now we can isolate the x by subtracting b over 2a from both sides. So x equals negative b over 2a plus or minus the square root of b squared minus 4ac divided by 2a. They already have a common denominator, so x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And hopefully that answer looks familiar, because what we just did is we developed the quadratic formula. That's why the quadratic formula always works. Completing a square is great when your leading coefficient is a positive 1. Negative 1's not so bad, but once you get a leading coefficient of 2 or 3, you might end up with a lot of fractions that make it more difficult to use. That's why the quadratic formula is so helpful, because it works and it makes it easier for us not to have to deal with a lot of fractions. So even though completing the square is good, it's not necessarily great in all instances. If you can't factor a quadratic, the quadratic formula always works. Completing the square works, but it might get messy depending on the problem. Okay, thank you, and I will see you in the next one.